We will talk about the histories. First, we discuss the race to the top. The desire to build big is nothing new, stretch the limits of what's possible, and even as simple competition among owners, families, architects, and builders. Some of the most dramatic buildings of the past include the pyramids in Egypt, the skinny towers stretching towards the sky in Italian hill towns, and the Gothic cathedrals of France. While these types of buildings may look very different from each other, they all have one thing in common. They were built with masonry or stone walls supporting most of the weight, so-called load-bearing walls, including that of the floors, the people, and everything the rooms contained. Because of this, the height of these buildings was limited by how massive and heavy they had to be at the base. Removing the obstacles. Two developments in the 19th century paved the way for a whole new type of building. The first was the development of a safe elevator. Primitive elevators of various designs had been used for centuries, and starting in the mid-19th century, steam-operated elevators were used to move materials in factories, mines, and warehouses. But these elevators were not considered safe for people. If the cable broke, they would plummet to the bottom of the elevator shaft. Then in 1853, an American inventor named Elisha Graves Otis developed a safety device that kept elevators from falling if a cable should break. This new development had an enormous impact on public confidence. And later in the century, the switch to an electric motor made the elevator a practical solution to the problem of getting up and down tall buildings. The second development took place in Chicago. In 1871, Chicago suffered a devastating fire. In the years that followed, however, instead of recovering slowly, the city experienced explosive growth, and it quickly began to strain against its natural boundaries. By the 1880s, the available land for new buildings in this area could not keep up with demand. The only alternative was to build up. But in order to achieve the desired height, construction techniques had to change. A new method of building was developed that used a grid of steel beams and columns that were strong enough to support any stresses or forces a building might experience, including both the weight of the floor and the building contents, as well as the force of wind or even, in some areas, earthquakes. And with this new building method, the skyscraper was born and the race for the tallest building began. Looked for ways to improve building methods and materials, in order to make structures stronger, taller, and lighter. Skyscrapers are built to last, so they must be made of materials that are strong, durable, resistant to the sun, wind, rain, frost, and snow, and affordable. Concrete is one of the most common materials, beyond the steel supports, because it is enormously versatile. Its composition can be changed depending on the needs of the building. It can be reinforced to make it stiffer and stronger by setting steel mesh or bars into the concrete. And additives can make it set or harden faster or slower depending on the needs of the design. Another very important material is glass. Because the steel skeleton now supports the main loads of the building, the outer skin only serves to keep the weather out and let light in, the lighter the better. So glass walls became very popular beginning after World War II, because they are weatherproof while providing ample natural light, and also because they are so much lighter and cheaper than masonry or concrete. The forces of nature. But as buildings became taller and lighter, particularly the modern glass boxes that are so popular, skyscrapers began having trouble with the wind and they began to sway, some more than 2 feet in any direction. Engineers came up with new solutions for this problem, first installing diagonally braced steel trusses between central elevator shafts to create a stronger core, and then moving most of the beams and columns to the outside edge of the walls in order to make a stiff tube. A more unusual solution was devised to control sway in the 1970s called a tuned mass damper. This is a giant concrete block or weight, mounted with springs and shock absorbers on a lubricated plate, designed like a pendulum to move in one direction when a computer senses the structure has begun to move in the other, in order to counterbalance the motion. Building badly. Of course, with new technological developments, problems can occur. One dramatic and very visible example was the John Hancock Tower in Boston, now considered the city's most spectacular building. The structure is a tower of mirrored glass. But almost from the beginning, the glass panes failed. The problem started during a winter gale in January 1973 while the tower was still under construction, when huge panels of glass, each weighing 500 pounds, shattered and fell to the street below. The streets and sidewalks were roped off as engineers tried to figure out what was going wrong. By April, at least 65 panels had fallen and been replaced by plywood. Theories and rumors persisted, including that the tower was swaying too much, causing the windows to pop out, or that the tower's foundation was settling so significantly that it broke the windows. The truth was that the material itself failed. The window units had been manufactured using a fairly new process and the design was fatally flawed. Ultimately, all 10,344 windows had to be replaced and the building has been safe ever since. The race for the sky. In the early 20th century, corporations built skyscrapers for the promotional value to increase name recognition. Among the early skyscrapers in Manhattan were the Metropolitan Life Insurance Tower, 700 feet, 50 stories, the Woolworth Building, the world's tallest from 1913 to 1930 at 792 feet, 60 stories, the Bank of Manhattan, 927 feet, 71 stories, and the heavily decorated Chrysler Building, briefly the world's tallest in 1930 at 1,046 feet, 77 stories. The Chrysler Building soon lost its crown to the Empire State Building, built during the Depression by a real estate developer, which reached a stunning 1,250 feet and 102 stories. The Empire State Building would reign supreme among skyscrapers for 41 years until 1972, when it was surpassed by the World Trade Center, 1,368 feet, 110 stories. 2 years later, New York City lost the distinction of housing the tallest building when the Sears Tower was constructed in Chicago, 1,450 feet, 110 stories. And 24 years after that, for the first time the tallest skyscraper was no longer in the United States at all, but in Kuala Lumpur, Malaysia, where the Petronas Towers were built in 1998, 1,483 feet, 88 stories. Taipei 101, completed in Taiwan in 2004, which tops out at 1,670 feet and 101 stories, held the title as the tallest building in the world until January 2010, when the Burj Khalifa, in Dubai, United Arab Emirates, became the world's tallest building at 2,716 feet, 828 meters, and 160 stories. The Burj Khalifa contains the world's fastest elevators, 20.7 acres of glass, and is expected to use about 250,000 gallons of water per day. The history of skyscrapers is very interesting. Please let us know. Thank you for watching and see you in the next